let's get started. We're going to talk about how to plan and track on Agile projects. I don't want to bore you with a bunch of my background, but I want to tell you one thing because it's going to be interesting and relevant to what we talk about. The late 90s was a great time for me. I worked at a good company with a really good CEO, kind of the one time I had a really good CEO. And I took advantage of the situation to get good at estimating and planning. Not necessarily me, but the teams I was working with. I was VP of engineering there, and my CEO understood that not every project needed to go be a big blockbuster and make a lot of money. Not every single project needed to come in on exact the right date. That we would be late sometimes. Some projects would make a lot of money, some might lose money. But overall, we had a good portfolio of ideas, and that was more important to this company. So I took this opportunity to help my teams get good at estimating and planning our projects. And what I told them to do was that every project had to be estimated in a different way. And I put in two simple rules. This first one was really easy. You had to tell me what you were doing. I wanted to know what they were doing. I was not going to approve it or anything like that. I just wanted to know what people were doing because I wanted to get good at this. I wasn't good at it. And the second rule was you had to do something different. You couldn't do exactly what the other teams did. This worked out to be the most important rule because it led to a very quick kind of Darwinian survival of the fittest idea approach. Because let's say you're starting a project in November, you would look at all the projects that had gone before. Yeah, maybe they weren't totally done, but they were halfway through and they were on schedule and that looked promising. And you'd look at a project that had gone before and you'd say, wow, I want to do what they did. Well, maybe they only got lucky. Maybe they didn't really have the right estimating process. They got lucky. Well, you'd come to me and you'd say, I want to do what they did. And I'd say, you can't do it. You got to do something slightly different. So they would find some slight variation. If that worked well, the team that maybe started in February would look at what you had done. It was a minor improvement. You'd go with that. So it's led to a very quick evolution of ideas. And I'm going to talk about some of the things that evolved through that period because some of them were very minor. I did not make people change it in a big way. Some of the variations were very small. So we went through ideas very quickly as a good way to become good estimators, more importantly, good planners of our projects. So I want to talk about how to estimate and plan software projects. But what I'd really like to talk about is, suppose you've been doing this a long time, right? We're here at Google, and I appreciate Google having me out here, but a lot of us have been doing software a long time, and we're fed up, right? This is a tough job. We got to think hard, and, we get deadlines, and sometimes we're here late. It's stressful. What if we decide enough's enough? I'm tired of software development. Let's all go back to our one true love. Let's go into the landscaping business, right? High growth industry. Let's go into landscaping. Sounds more fun. Well, the first job you've got, I'm going to hire you. I've got a big pile of rocks, as you can see, in my front yard, and I need to move this pile of rocks into my backyard. I'm from Boulder, Colorado area. We got snow on December 20th. You might have seen our blizzard in the news. It's the one that shut down our airport for days and days. Well, up until about a week ago, we had snow still on the ground. This never happens. I used to live out this way. I never would have moved there, right, if I had known the snow stayed on the ground. And it normally doesn't. It stays on for a day or two. But we've had snow on the ground for 3 straight months almost now. So now that snow is finally gone, I do have a big pile of rocks that's uncovered. I now need to move it into the backyard. I've been able to get out of it for the last few months by saying it's covered with snow. I don't want to move it. Now I need to. So suppose we've got this big rock. How are we going to estimate this? Well, one way is going to be to look at it and estimate how many wheelbarrow loads are represented by that pile. Right? And then after an hour, let's just see how many wheelbarrow loads we've moved. Right? Based on how many we moved in an hour, we can extrapolate the total duration. Not big surprise that this technique might work this way. I think there's 80 wheelbarrow loads there. I work for an hour, and I've moved 20. I don't know what I was thinking when I made that slide up, because it's a very optimistic estimate of how many wheelbarrow loads I can move in an hour, but maybe I've moved 4 instead of 20. So if I assume I can do 20, I could do the math and say, well, there's 80, I've done 20, therefore I'm done in 4 hours. Very simple estimating approach, and I guarantee when I am doing this work this weekend, or maybe I can put it off till next weekend, this is how I'll do it. I'll think about it this way. What I won't do is this. I'm not this anal, but I could, if I wanted to, draw a graph of the progress, right? Might give me a good 2-minute break to go draw this, fire up a charting program. Now here I'm showing that I started out with 80, 1 hour later I'm down to 60. So I've got this little graph of my progress. Well, okay, we're not going to make as much money if we go into the landscaping business, so let's stick with software development. I just wanted to tell you about my landscaping problem. So let's get some terms out. I want to make sure we're using some terms consistently. So I'm going to use the term iteration to represent a short, constrained period of time. It's a time box, typically going to be 1 to 4 weeks. Extreme programming teams tend to be on the shorter end of this. They tend to be 1 or 2 weeks. Scrum teams, another agile process, typically tend to be on the 2 to 4 week, a little bit more middle to the end side. Note that they overlap. There's a lot of overlap between Scrum and extreme programming, of course. So anywhere between 1 to 4 weeks, maybe a month, a calendar month if you want. So that's an iteration. Now we're going to have a couple of those iterations on this diagram. I want to think about the term release. A release, typically multiple iterations. You may not actually release it. I do a fair amount of work with some video game development companies. Video game development companies can't do periodic releases. You know, if they're doing kind of like a AAA game that goes in a box, right? They have to release it one time. You know, then they get the next version out next year if they're doing like a football game or something. But they don't get to put out a release every 6 weeks, right? So those type of environments might break it down and say, well, we're not actually going to release this out to the world, but they're still going to think about in terms of a release, maybe a quarterly milestone. Where are we going to be in a quarter? So a release is going to be multiple iterations. Within these iterations, I want to put in some work, right? I'm going to put in, I like to think of these as user stories, the requirements, the features that we're going to do within the iterations. So let's assume that we've put in these units of work. So what I've done here is I put in some units of work, the smaller boxes with some numbers on them, some labels. Right? I've got this one here is a 4, right? It's about twice the size. You know, that's a bad one. That's mislabeled. This 4 is about twice as, let's call it misestimated, right? I did that on purpose, right? This one's a 4. It's about twice the size of the 2. It's about 4 times the size of the 1. We're going to talk a lot this evening about how to put these numbers on here. For now, let's just assume they've somehow got on there. So I have some estimates on these units of work, typically user stories for me. We're going to talk about a term called velocity. Velocity is the amount of work planned or completed within an iteration. So in this case, let's see if I can add one of these up. On the left there, I've got 15. Right? This one over here. This iteration, we're planning to get 15 units of work done. I use the term units of work. Agile teams typically estimate in 1 of 2 units. They typically estimate in what's called ideal time, or they estimate in what's called story points. We'll talk mostly about story points this evening, but both units work. So velocity is going to be a measure of the amount planned or completed in an iteration. So we may hear the terms like planned velocity. Our planned velocity is 15. That's what we're planning to get done in the next 5 iterations, 15 points per iteration. Or we may talk about an observed velocity. We ran the last iteration and had an observed velocity of 16, one better than our planned velocity. So you may use the terms that way. Just some terms I just want to get out. When we think about planning on an Agile project, planning occurs at multiple levels. I like to think of this as an onion, a planning onion, right? I like that, right? Planning kind of stinks on most of our projects. Onions stink, so I like to think of them going together that way. So we've got the daily plan here at the bottom. Where do teams make their daily plans? Yeah, at the stand-ups, right? Daily stand-up, the daily scrum, whatever you call it. We have the iteration plan. Teams get together at the start of an iteration. Say, what can we commit to in the next 2 weeks? 4 weeks, whatever it is. They make an iteration plan. We have release plans, right? Where are we going with this thing in the next 3 to 6 months? Again, even if it's a 2-year game or a 2-year big, huge project, we're going to break it down into a little bit smaller things. Product planning. Where's this product going over its life? Right? Well, in 07, we'd like to do this. In 08, we think we'll do this. I'm not really sure what we're going to do in 09, right? So some level of product planning. Portfolio planning. Right? Does this product even fit in our portfolio? Where are we going? Right? Google's an interesting example, right? We're here at Google tonight. You know, I'm trying to, always when I do this, I'm trying to think of an example of like, well, you know, I bet your company wouldn't do this, right? No, being at Google, it's hard to come up with an example of what might not be coming next, right? One of the jokes was we were, you know, somebody before we got started was joking about, well, we might be working on a cloning system, right? Who knows, right? So, you know, normally the joke I can make is, you know, I bet, you know, you're sitting back at your desk at work tomorrow and you come up with a great idea for an operating system. You go to your boss and you say, hey, we'd like to do an OS, right? Doesn't fit in the product portfolio. We're not going there. Right? Well, I don't know if that works here, right? We might be coming up with some sort of OS over time. So do things fit in our portfolio? What's our company's strategy, right? Where are we going? What are we trying to do, right? Maybe we decide to come up with a new printer, right? That probably doesn't fit in the portfolio or the company strategy here, right? We're not likely to switch to being a hardware business. So Agile teams plan at these three bottom levels. Somebody in the company is planning above here. Product owners, typically, Scrum calls them product owners. They're responsible for a level or two above this. Product owners typically aren't very involved in the daily plan, but they will be involved in the iteration release product plan, maybe the portfolio plan. Further up the organization, we're going to have product management, executive staff, those types figuring out the portfolio and strategy. But Agile teams are going to plan at these lower levels, these three lower levels, and these are critical for the execution success of projects. Now, I want to show how these three levels relate in my mind. And this is an interesting picture. You're going to see this slide later. I'm going to bring this one back in a half hour or so, and you'll see this in a slightly different context. So Agile teams plan at these three levels. On the left here in the blue, we show Agile teams planning with their what's called their product backlog. This is a Scrum term for a requirements document, essentially. Product backlog, a feature list, what we plan to do in here. When I first started doing Scrum for the very beginning, back first project I ran, we started doing Scrum in January '95. We didn't use the term product backlog. Ken Schwaber hadn't started writing about Scrum, so I hadn't come across that term. We just called this a prioritized feature list, right? It was just a prioritized list of the things that were desired. I do use the term product backlog these days, of course, but prioritized feature list is a little bit more descriptive of what it is, so I mentioned that as a term right now. So we have this list of things that we'd like in there, and I want to have some sort of size estimate on those. Associated with this, we also have an iteration backlog over here in the green to the right. The iteration backlog is the list of tasks and the hour estimates for those tasks. Now, there's a lot of debate about what's the right unit for the product backlog. All right, we've got these things over here. I've written these kind of in the form of user stories, short, simple statements told from a user's perspective. And we're going to talk mostly about story points over here, but there's a lot of debate. Maybe you want to do ideal days. There's not a lot of debate on the iteration backlog over here. This is tasks and hours. Right? I have seen teams doing other things. They'll put some sort of point over there. I've never heard a good argument for doing so. You're about to do the work. You're planning your iteration, your 2-week iteration, 4-week iteration, whatever it is. You're in a meeting planning the work you're about to do in the next couple of weeks. You should be able to take a guess in terms of the number of hours. Right? Teams that want to do it in something other than hours are really just kind of saying, well, we can't estimate this, and we want to put something on here because we have to, but we can't estimate it. Normally they mean they're afraid of being wrong. Right? They're in a company where there's too much pressure to be right on these things, and they're feeling too much pressure on this. And that needs to be removed from the team because, yeah, some of these estimates are going to be high, some are going to be low. It's just a tool to figure out what we commit to during an iteration. So no debate in my mind on the right side here. This should be tasks and hours. Right? On the left, down here in the red, this is the iteration, the daily stand-up. At the daily stand-up, the level at which we plan is promises or commitments to our peers. Right? One of the nice things about doing this as a stand-up meeting is we don't stand up very often at work. Right? And so we stand up during the daily scrum, the daily stand-up meeting, and say, I will work on this. That's a nice commitment to your peers. Right? All you're committing to doing is not getting pulled into 32 other meetings. Right? Not necessarily saying, I will finish this or I will do this. In a lot of companies saying, I will work on this, that's a big commitment. That means I won't get distracted into 14 other things. So it's a big deal. So 3 different levels we're going to plan at. I just want to show this picture about how they relate. We've got product backlog on the left. Individual items on there get broken down into tasks and hours. During the project, during the iteration, day by day, we make promises or commitments to our peers. This here is a diagram of the overall picture of what Agile planning is going to look like, in my opinion. I start out up here with release planning at the top. Release planning starts when somebody brings to the team a set of conditions that they hope they can have satisfied. They come to the team and they say, I'd like this much. I'd like this scope. I'd like it by, let's see, we're here on March 20th. I'd like it by June 20th. I'll give you 3 months to do this. And you can use the team you have and 2 new hires. or you can move 2 people from that other team. So they bring us a set of features, a set of resources in mind, and a deadline in mind, scope, schedule, and resources. And the team, their job is not to say, yes, we'll go do this. Right? If they can, they should say, yes, we'll go do this. But their job most likely is to explore the solution space, figure out how we can best satisfy this person requesting the software. So I've shown this as an iterative process. That's the red arrows up there. We do release planning by trying to figure out how can we best satisfy this someone who is after something more than we can probably deliver. Because that's typically the situation. And I don't mean that in a negative way, that our product managers are after more than we can deliver. I mean that in the same sense that when I go to Best Buy or Good Guys, there's more in there than I can afford to buy, right? I go in there looking for a nice TV. Well, I'd like the bigger TV, and I'd like one for the kitchen too, and oh, new speakers would be nice, right? We always want more than we can have. So I don't mean this in some dysfunctional product managers trying to put us under the screws way. I just mean we want a lot of stuff, right? How can we get it done in time? So we do release planning. And we iterate over that. We explore the solution space to figure out how best to meet their needs, to satisfy their conditions of satisfaction, their expectations for a project. That's release planning. We also have a level of iteration planning that occurs. Notice that iteration planning is going to start out with the same pattern here. I've got a set of conditions of satisfaction that come down, but I've only brought down the scope for the iteration planning. Right, up above, I have the scope, schedule, and resources. Why do you think I didn't bring down the schedule and resources into iteration planning? What do you think? Yeah, I already have the schedule. These are essentially fixed. Right? Agile teams have learned that it's good to have a fixed rhythm, a cadence to their projects. I tend to like 2-week iterations, what Scrum calls a sprint. So I run 2-week sprints, 2-week iterations. Every 2 weeks, we do iterations. Right? I don't start them out by saying, how long should we do this one? And we do a 4-week, and then a 2-week, and then a 3, and then an 8, and then a 2. Teams have learned it's nice to have a consistent rhythm. Right? So the schedule isn't really negotiated during iteration planning. Neither are the resources. In most environments, it takes more than one iteration to begin to blow the budget. Right? We want to spend more money. We need new hires. Well, we may get that approved, but it's certainly not part of iteration planning. It takes longer than one iteration to even bring somebody on in most environments. So iteration planning is iterative as well. We look at the iteration. We try to figure out how best to start to satisfy our expectations from our product owner or customer. We iterate over that, trying to figure out what should be built in the iteration. We develop some software. We end the iteration with potentially shippable product. Something that's truly done, something we may not choose to ship it, but I want it done enough that I can look at it, I can poke it and prod it, see how it works. I can show it to people and say, what do you think? Right, what should I do next? How do you like this? I can get feedback from it. Some of the things we might be feeding back, maybe feeding back information on the quality of the release, of the potentially shippable increment. How are we doing on a quality level? How are we doing in terms of the features that we've added in? What do you think? Do you like these features? I may get feedback by showing this to people. They want new features we hadn't thought of. I may get feedback that features that we have thought of are higher or lower in priority. Let's move our product backlog around. I'm going to get feedback based on how fast the team is moving. Wow, this team's going really great. They're going very quickly. Let's accelerate the release date. Or, well, the team's going at a pretty good pace, but we're adding new ideas. Maybe we need a second team on here. So all these types of feedback are going to be filtering in to what we're doing. Okay? So this is an overview of the high-level process. Here's the 3 things that we're going to talk about now. We're going to talk about how to estimate. This is the hard part of what we're talking about tonight, estimating and planning. Estimating is hard. Planning, when we get to it, is actually going to be really simple. And then we're going to talk about something called a burn-down chart. So I wanted to make sure we talked about estimating and planning and tracking tonight. So those are kind of the 3 things that we're going to talk about. By the way, I don't have the last block of time reserved for questions. So if you have questions, please just ask them in context. So if I'm talking about estimating, ask me an estimating question. If you ask me about burn-down charts, I'll say, wait a few minutes. We'll get to that, right? But generally, in general, ask me questions. I'd like to take them in context. Because if you have a question, probably lots of other people do. So let's talk about story points. I just said I want questions, and I tried to move on without getting one. Oh, yes. Can you get copies of the presentation? Yes, I'll have them available for a price. So, no, I'll have them on my website hopefully tonight. So, assuming the connection in the hotel is fast enough to upload things, I'll have them up on my site. So you can go to mountaingoatsoftware.com, and then there's a presentations tab, and it'll be up there. So I meant to try to get it up there this morning, but yeah, this will all be up there. I put everything up there, so even things that I did at the software development conference is up there. That'll be up there tonight as well. I put everything up there. I'm not real big on kind of treating this stuff secretly. Story points, probably the most common technique for estimating today. I think teams have started to realize this is a good approach, and I've been pushing this pretty hard over the last couple of years as the best way to estimate. So a lot of teams have switched and begun to estimate in story points rather than other techniques like ideal time. It's a very common approach. The name story points comes from the kind of the product backlog or requirements technique of user stories. So we estimate user stories, requirement statements, in story points. The idea of a story point is it's essentially a combination of the size and complexity of the work. Now, if you think about the size and complexity, if you add those two things together, what you really get is the duration, the amount of time that something's going to take. So story points are about estimating the time that something's going to take, but we're going to estimate them in unitless but numerically relevant numbers. What I mean by that is we're going to call something a 5. The other thing we're going to call a 10. What that means is the 10 will take about twice as long to do as the 5. It's about twice as big as a 5. Now, unitless in the sense that I don't care if you use 50 and 100, 5 and 10, right? I actually encourage you to use fairly big numbers, right? The reason I want you to use fairly big numbers, let's say we estimate in the billions, right? This is going to be nice because at some point, your boss is going to be hanging out at a cocktail party with another Agile boss, right? They do this. You may not know this, but they go to cocktail parties and talk about their teams. Now, if you're estimating the billions, your boss is going to say something like, oh, my team has a velocity of 13 billion, right? What about the other boss who's going to say, well, wow, my team only has 46. You're getting 13 billion, we get 46, right? Your boss is going to come back really proud of you. The bonuses will be flowing, right? The point of this silliness is that they're not comparable that way. There are things we can do within an organization to standardize what a story point means, right? So we can go into your company and we can get a story point to equal a story point across all teams within one company. We can't do it worldwide. We're not going to do it across the whole software industry. But within a company, we can. If you're interested, remind me and I'll tell you how you can do that. We still got that landscaping stuff in my front yard. I told you about the rock. I didn't tell you about the big pile of walk-on bark that I have too, right? I've got another part of my backyard that we want to put these tree shavings down in. We had some kind of drainage issues, and we're going to fix that by mostly just covering it up with a big pile of bark. So I've got these two big piles of landscaping material in the front of my yard. They're in about the same place in the front yard, close enough that it's not going to affect our estimate. They happen to be about the same size. I know that within a very small margin of error, they are the same size because I paid the landscaping company to deliver piles of the same size, right? I ordered the same amount of each. And they're essentially going to the same place in my backyard. One over here, one over here. They're essentially going to and from the same distances. What estimates might we put on those, right? Say we look at that drain rock, the great big rock. I'm going to put, let's say 100 on there. Now, if we've called the rock 100, what do you want to put on the same size pile of a lighter material going about the same distance? What? 30. I heard a 30. Let's go with 30. So with 30, we're saying that's going to be, I can do that about a third of the time, right? So moving the rock will take me about 3 times as long as moving the bark will be. I can buy that. When I go to shovel the rock, that's kind of hard, right? I have to shovel the rock. I've done this before. I know that sometimes I'm shoveling it and I tip the shovel, right? And the rock falls out. Every now and then I get the wheelbarrow half full and it tips over because I haven't loaded it evenly and I got to start over, right? The bark is really easy. Just shovel it in. It's actually kind of fun to, just don't tell my wife that. But it's actually kind of fun to shovel the bark in, right? That doesn't bother me. The rock, yeah, you got to take a break. That stuff's hard to do. I don't want to do that all day. The bark is going to be fun. The rock, not so much. So we've put numbers on these. We put 130, or we put 100 on one and 30 on the other. Okay, again, that has nothing to do with what we're talking about. We're talking about software. So let's skip the rocks for a few minutes again. I just like coming back to that because you guys are now helping me figure out how long it's going to take to do this work I've got to do at home. I've been talking long enough. We got all this great food here. Google's renowned for its food. I'd like to get some. So what I'd like to do while I'm doing that, I'd like to have you do something for me. I'd like you to estimate in zoo points a few animals I've got up here. Now we're going to define a zoo point as a combination of the mass and volume of the animal. Right? So it's not just as simple as taking its weight. I want to make it a little harder than that. So kind of the mass and the volume. Right? A giraffe's got a lot of volume, real tall, right? So a combination of mass and volume. Estimate in zoo points these 8 zoo animals, okay? Do these in little small groups. One of the fundamentals of Agile, by the way, is self-organizing teams. So I'm going to let you self-organize. So self-organize into groups of probably 4 or 5. We're going to do this. We're going to do one more fun exercise later where you're going to be in groups. So, be in a group of 4 or 5. This, it really doesn't matter how big you are, but later we're going to want to be in 4s and 5s probably. So I'd encourage you to start out that way. So go ahead and do this for a few minutes while I get some of the good-looking food. Okay, let's come back together and see how we've done with our 8 zoo animals. Which group has it right? You do?
I don't know.
You guys in the back have it right? Is that what I'm...
What is the definition of right?
I just need a group that we can use as an example. That's all I want. Okay, let's go with yours. What did you come up with for lion? 10. Everybody okay with 10 on a lion? Yeah, it's hard to be wrong on the first one. Okay. What about kangaroo? 8. Kangaroo about 80% of a lion. Everybody? No? Kangaroo smaller? Smaller than that? They're kind of tall, right? Aren't they about human size? Okay. What about rhino? 15? Okay, so we got a 15 on a rhino. By the way, I'm sure that you mean these numbers in the billions, right? But yeah, a common Agile convention is to just drop the billion, right? So you're already ahead of me just dropping the billion. So a rhino's a 15. It's about 50% bigger than a lion. Everybody okay with that? It's a lot bigger than a lion? Okay, what about bear? 10. So a bear's about the same as a lion. Well, I meant those. Well, I meant those little guys that live in Australia, the cute ones I see at the zoo. Yeah, koala bears. These guys, right? They're vicious. Well, they're not as big as a lion. I mean, we're not rating viciousness, right? I mean, that's not a 10. How'd you put a 10 on this guy? So you were thinking of black bears or grizzly bears. Well, you didn't ask me. I'm your product owner. Nobody asked me. You guys did. You guys did. Okay, I was off enjoying the food. I wasn't that far away, though. Yes, one group did ask me, and I said I didn't want to answer. I said you were on to me, and I wanted to set up some other group for being wrong. Don't worry, if you had said, oh, we think they're a 2, we're thinking of panda bears. I would have said, panda bears, I'm thinking of the great big grizzlies. Right? I would have got you either way. Did anybody estimate bear in a range? Did anybody say, well, they're kind of small to kind of big? You guys have them as a range? No? You did with a gorilla. Okay. So let's keep going with these. What about giraffe? 13. Giraffe's a 13. So a giraffe is in between a lion and a rhino. About kind of halfway in between a lion and a rhino. This is a pretty small rhino. I've seen them. They're bigger.
A baby rhino.
Oh, baby rhino. Okay. So we could keep going through these. Now we've got a group here, right? More than just the group that estimated this. And with the collective wisdom of all of us here, we could probably refine their numbers a little bit. Maybe we'd up Rhino a little bit, right? The rest of us could talk them into a bigger number on Rhino. Right, so we could refine their numbers, and among the group here, we could come up with slight improvements. Now this is key in the sense that the wisdom of the crowds type of a concept, right? Remember the Who Wants to Be a Millionaire show, right? And you had two ways or a couple of ways to get advice. One was to have your smartest friend available on the phone, right? And a lot of us have some pretty smart friends that know all sorts of weird trivia. Yet our smartest friends, based on what the experience from that show, our smartest friends were not as smart as stray people who happened to be in the studio answering the question, right? Right? There's a lot of wisdom when we put a bunch of people together to figure things out. So as a group, we might have been able to come up with slightly better numbers. On the other hand, what if I'd thrown out some different items at you? I said, well, as your product owner, I meant to include a couple other items on here. What about Indian elephant, right? 30. So an Indian elephant is about twice the size of a rhino? They seem a lot bigger. What about blue whale? 1,000, 100, right? It turns out we're pretty good estimators when we stay within one order of magnitude, right? 1 to 10, 10 to 100, or 1 million to 10 million, whatever it is. Within one order of magnitude, we're pretty good. When we start to go outside of an order of magnitude, that's when things start to go wrong. Right now, often on our projects, we do have to estimate some things like this, plus a few blue whales. Right? Just be aware that when we're estimating those blue whales, there's a lot more uncertainty in those. And if you got a lot of those, you may need to express your overall project in terms of a range. Well, we'll be done in third quarter, right? Instead of saying October or instead of saying August. You might have to say third quarter. You may have to have some uncertainty in there when we have a lot of these things. Let's go with a different group. How did you guys get started? You other team in the front here. What did you do to get started with this?
I said, let's just call them all 10, and then let's find the ones that obviously aren't right, and then fix them.
Okay, interesting. So you just gave them all a 10 and then said, what looks wrong, right? In the back, what did you do? Okay. Okay. So you ranked them by size first, kind of did a bubble sort of the zoo animals, and then it was easier to put them on there, right? Well, that works until we're doing, a couple hundred items, right? Right? You always teach these classes, and I give people 8 or 9 things to do, right? And it's a little different than we go to our real world and we got 100 items on our product backlog, right? So we might have to do a more coarse-grained sort if we have 100 items. Any other techniques people use to get started? What did you guys use? Okay, so some loose bucketing of them, right? Okay, the wine and the tiger are about the same size. This and that are about the same size. Bins, the same type of thing. We got to make sure the SPCA isn't listening, right? In case we're saying like, oh, we put the animals into some loose bins and then, then estimated them, right? That's not going to sound real good. Different approach? Okay, so you established a range. Let me drill into that before I answer the question. So you established a range. Did you have a 1 and a 100 in here? Okay, so you picked 100. You picked 100 for the big animal. Which was your biggest? Hippo? So the hippo and rhino both got 100. What was the lowest number you used? Okay, so you said, let me see if I can paraphrase what you really did here, is you said, we'd like to put things in a 1 to 100 range, so we're going to think about them that way, and then you thought about your biggest, you put 100, and then you estimated all the rest, and you didn't end up with a 1 to 100 range, you ended up with a 50 to 100 range. Yes, let me get there. So you've left yourself room below. There's always room above, right? We can always go bigger. We can go smaller, but doing things in decimals starts to be real silly, right? So you left yourself lots of room for rabbits and mice and little tiny ants, little tiny things down at the bottom. And that's good. I like that. What I was concerned with is when you said we set up a range, because I will see this, people will say, hey, let's estimate 1 to 100. And they'll say, what's the smallest? Oh, kangaroo. Let's give a kangaroo a 1. What's the largest? A hippo. Let's give that a 100, right? And that would be false because, they're not 100 to 1 size difference, right? So it's fine to say we'd like to use a range of 1 to 100, but then do exactly what you did. Put them into there, right? I'd like the basic math properties to hold when we estimate this way. That sounds complicated. All I really mean is 4 2 should be about the same as an 8, right? The basic math properties should hold. The other thing that it turns out that helps us be good estimators is relative estimating, which is what we just did, right? Estimating the relative size of things. There's a professor at NYU, New York University. He asked his students to estimate the height of the Empire State Building. He got back estimates that ranged, on the low end, from 200 feet. Imagine that for a second. Imagine tipping the Empire State Building over and having it be smaller than a soccer field, right? 200 feet to 2 miles, right? 3 kilometers, 2 miles high. Right? Imagine looking up and seeing that thing, right, in the sky. Okay? We are bad at absolute estimating. We are not so bad at relative estimating, right? If we had to think about the fear. If I told you that your career is dependent on you estimating how many pounds a rhino weighs, that would be really hard. I would be nervous about that. What if I said instead that, well, your career rests on you estimating how much bigger a hippo is than let's make it a gorilla, right? And I'm going to give you a day. You can't go get on the internet and figure it out. I'm going to give you a day to figure this out, right? I would much rather estimate the relative size of things, right? It's much easier for us to do. A couple of reasons why this type of estimating works. Focuses on the relative estimating, what I just talked about. And there's studies that show we're better at this. I've got these referenced down there. Doing estimating this way focuses on estimating the size of things, not the duration. Right? We then derive the duration empirically by seeing how fast we move through the project. We've all heard the old jokes about, weigh the requirements document, right? Or analysts who, want to weigh the requirements document, right? Well, imagine you actually could weigh the requirements document meant something. So imagine I weigh a requirements document, it weighs 300 pounds. Well, then in the first iteration, we weigh the part we finished, and we've finished 20 pounds of requirements. Well, now I know that I'm done in 15 iterations. Right? We're trying to come up with a way of doing that type of thing. Figure the size of the project. And imagine I asked you to estimate how long it would take to read the new Harry Potter book that's coming out, next month or something like that? I ask you to estimate how long it's going to take to read that book. You look at the book, picture of the book that was in the news, you look at it and say, oh, it looks like about 700 pages. And then you think about how fast you read, and you say, well, I bet I read about a page a minute, 60 pages an hour, 700 pages divided by 60, that's about 12 hours, right? And you say, I'll bet I'm done in 12 hours, right? That's estimating the size, deriving the duration. This is a best practice way to estimate. It is how we estimate in the real world. I'll give you another example. Suppose I ask you to estimate how long it'll take to drive from here to Austin, Texas. You might think about, well, let's see, Austin, Texas, how far away is that? You'd come up with how many miles it is based on some guess. You'd think about how fast you drive, right? Factor in the traffic when you're driving, all those type of things. You'd do the math, you'd figure out the duration. So estimate the size, derive the duration. Put estimates in units that we can add together. Time-based estimates are not additive. This is the big fallacy in time-based estimating. This is one of the biggest reasons I prefer story points. I'm a really crappy runner, but I still like to run 5Ks and 10Ks, things like that. I'm too big to be a good runner, but I still do it. I enjoy doing it. I'll probably go for a run later tonight. I've also got a foot injury, slows me down even more. Anybody here a good runner, though? Anybody like to go do 5Ks or 10Ks? No? I'm not going to pick on you. I just needed an example. Well, let's suppose somebody is, right? Well, we got Laura over here in our control room. We'll pretend Laura's a great runner, right? She's probably giving us dirty looks now, right? So I needed a volunteer somewhere. So Laura and I are standing at the start of a trail, and she says to me, Mike, that's a 5-minute trail. I say, no, it's not. It's a 10-minute trail. I ran it this morning. In fact, it's still on my stopwatch. 10 minutes and 2 seconds. She goes, well, I don't care that you ran it this morning. I live here. I run it every day. It is a 5-minute trail. She and I argue back and forth, 5:10, 5:10. You've been in these arguments, right? You've seen your developers have these arguments, 5:10, 5:10. We continue the argument. We eventually decide, let's call it 7.5. Now we've just done something really stupid. It's not good for her, it's not good for me, right? She's done 2.5 minutes early. I'm still out panting on the trail past the deadline, right? That's not a good compromise to make. We continue the argument. 5:10, 5:10. Laura says to me, Mike, it's a 1-kilometer trail. It takes me 5 minutes. I say, exactly. It's a 1-kilometer trail. That takes me 10 minutes to run. Right? When we put it into a size, we could agree. Yes, it's 1 kilometer. Right? So we can agree on size even though we do it at different rates. She runs it twice as fast as I do. So time-based estimates are not additive because we're always thinking, my time. This would take me 2 days to code. Might take you 2 hours to code. You're a lot better than I am. Right? So time-based estimates can't be added, but we can add size estimates. Right? This would take me 5 minutes to run. It would take you 2 minutes to run. Right? We can add those types of things. Okay? Yes? So the question is, what do we do if we have people with different skill levels, right? How can we possibly estimate if we have people with different skill levels? That's a hard question. So I'd prefer to not answer it. I'm not getting paid to be here. I'm not going to answer the hard questions. That's not satisfactory. What I'd like to do instead is I'd like to tell you about my daughter. I have a 7-year-old daughter, Delaney, at home, and she's going to help me with the landscape, moving the landscape stuff. She'll help me. She'll help me with the landscaping. So I've got those 2 big piles in the front yard. Now, my 7-year-old daughter does not know cubic volume, right? So she and I can't go look at that and say, oh, it's 5 cubic yards, right? Which I know it's 5 cubic yards because that's what we paid the landscaping company to deliver. She doesn't know cubic yards. So let's say she and I go look at that pile of rock, the rock first. We look at the pile of rock, and I want to estimate in something that she understands. 7-year-old daughter. 7-year-old kids drink milk. She knows what a milk jug looks like, right? A 1-gallon milk jug. So we decide, hey, how many milk jugs does that look like? Right? And we think about that, and we say, well, it looks like 100 milk jugs stacked up. It'd actually be a whole lot more, but let's just use 100 because it's easy. So she and I agree that that looks like 100 milk jugs stacked up. Now, in my head, I'm thinking about how I'm going to do that work. I'm going to do that work by shoveling rock into a wheelbarrow, walking it into the backyard. Delaney, my 7-year-old, is thinking about, let's see, I'll put my little sand pail on the ground, and I'll put rock into the sand pail, and I can probably fill it full and carry 1 sand pail at a time into the backyard. So she's thinking about doing the work at a completely different rate than I am. She has a different set of skills. She can't lift a heavy wheelbarrow of rock, right? So I am answering the question. On the other side of my yard, I have that bark, the white tree shavings. So I look at that, and I'm going to go with the 30 that we had yelled out earlier. I look at that and go, hey, if this one was 100 milk jugs, this pile's actually about the same size, but I can do this a lot faster. And I tell Delaney, I say, Delaney, I can do this a lot faster. It's easier to move. I bet I can do this in about, she doesn't understand percentages real well, so let's pretend she does, right? So I say, Delaney, I think I can do this in about 30% of the time. So I'm going to call that 100, or I'm going to call that 30 milk jugs, 30 milk jug points. And she might agree with me, right? Now, I'm thinking, hey, I'm going to put that in the wheelbarrow. I can run into the backyard. I can load that heaping full. Delaney's thinking about it going, wow, I've got 2 sand pails. I bet I can fill them both full and walk into the backyard, and I won't have to struggle. I can run into the backyard carrying two pails. So I've just shown an example where she and I have completely different skill sets, yet we can agree because we're not focused on the actual time to do it. We're focused on the relative size, right? Now, there's one fallacy in my argument. I'll point that out in a second, right? Because what I talked about is a situation where we can both relate to the work and we could both conceivably do it. I have a third thing in my front yard. I have 3 200-pound boulders. They're about 200 pounds is my estimate. I picked one up so I'd know. I can actually move that, right? I can pick it up, I can struggle with it, and I can carry it into the backyard. Actually, I can get it onto the grass, and from there I can roll it to where it needs to go. Right? Delaney, my little 7-year-old who weighs 40-something pounds, cannot pick up the 200-pound boulder, right? This is equivalent to some of the programming that we have going on, right? I used to be a pretty good C++ programmer. I'm still semi-decent in Java. I could go do some stuff at one of your companies if you want to hire me. I would like to do some programming, by the way. I love doing it. So if anybody needs a pretty lousy programmer, let me know. So I could go do some of the simple stuff you might need, but the hard stuff, I can't do that anymore, right? So this is an example where we have a person who can't even do the job, right? So in that case, Delaney may not be able to give me a real good estimate about what that should be, right? So she may not be able to contribute to the estimate because she can't even do that work and can't even relate to it, right? Now, on the other hand, my wife, who can't do the work, she can't lift up the 200-pound boulder, she could probably contribute to a discussion of the estimate, right? Because she could relate to that. She could carry a 50-pound sack of cement, so she could imagine how hard it would be to carry a 200-pound thing, right? So she could contribute to a discussion of that estimate. Does that make sense as an answer? Okay, good, because it's a fundamental question. It normally does come up. So let's go back to our product backlog here for a second. I want to make sure when we estimate things that we're comparing apples to apples as we estimate. Here's a common problem that can occur when we're planning projects. We've got a product backlog shown over here on the left in blue, and I've got some story point estimates on there. Again, on the right, iteration or sprint backlog, tasks and hours. Let me take the product backlog, watch closely, because I'm going to change those from story points to hours. I just want to make them bigger, right? I just want to put some bigger units on there. Here's what might happen if you estimate your product backlog in hours. Ideal hours, even ideal days. Ideal days is just a little harder because you have to multiply by 8. But let's assume that these are in hours now because it's convenient. So I've got a 30-hour task or 30-hour product backlog item up here at the top. When we go into the iteration or sprint, we plan that. We break it down into tasks. We estimate the hours. We come up with 35 hours. At the end of the iteration, we finished that unit of work. That one product backlog item has been delivered. We completed the 35 hours. What will happen next is someone will look at the remainder of the product backlog. 20 hours, 20 hours, 50 hours, 50 hours. They will say, we have 140 hours left in this project. Somebody will then say, well, how many do we finish per iteration? Well, we finished 35. What will they do with the numbers 140 and the number 35? They will divide them. They will take 140 divided by 35 and say, aha, we will be done in 4 iterations. Here's what I guarantee you will happen. You will not be done in 4 iterations. You'll be done in 5 iterations. The reason for this is these are not hours. These are hours we thought a lot about. The team on average spends 3 to 4 hours doing iteration planning. So let's not call those hours. Let's call them hours we thought a lot about. These over here, average team spends 2 to 3 minutes per item coming up with these. These are not hours we thought a lot about. These are hours we pulled out of the air or hours we pulled out of somewhere else. I can't take hours we pulled out of the air, divide them by hours we thought a lot about, and get anything meaningful. Question, yes? So the question is, if these were story points, would somebody do the same math? Let me hold off on the question for about 1 minute, and I'll show you why that won't be true. Okay? So I can't take hours I thought a lot, hours I pulled out of the air, divide them by hours I thought a lot about, and get anything meaningful. Right? The way I like to think about this is we have to be very careful about mixing before the fact and after the fact knowledge. What I mean by that is before the fact we thought things were this big. Before we did it, we thought they were this big. After the fact, we thought it was this big. Now, we can't mix before the fact and after the fact knowledge. I like the way philosophers talk about knowledge. Philosophers talk about 2 different types of knowledge. They talk about a priori knowledge, knowledge before we did it, and a posteriori knowledge, knowledge after the fact. Right? I don't want to mix before and after the fact knowledge. That's what we're doing in this situation. So here's the real math that should have happened, and this will get to the answer why this won't happen with story points. The real math that should have happened is we should have said, hey, before the fact, we thought there were 30 hours. This number up here. My pointer's not bright enough, but the 30 at the very top. Before we did it, we thought it was 30. Well, before we do all these, we think there's 140. So the real math should have been 140 divided by 30, and we would come to the conclusion, well, this will take essentially 5 iterations. Right? Which is why I contend that I wish I could confirm this, but I think it's every time I've seen this. But I can't say that for sure. So I'm going to say almost every time, although I think it is every. Every time I've seen this, the team ends up being 1 to 2 iterations late. Anytime I see them estimating in this type of way, they end up 1 or 2 iterations late because they're mixing the before and after the fact knowledge. Question? Uh-huh. So you had to essentially, so the question was management came back and said you had to do detailed estimates on the whole thing. And so you had to take everything to this task an hour level, correct? Yeah. The problem with that is it just takes a lot of time to do. And I don't know that it's any more accurate. If I thought it was much more accurate, I'd be okay with advising teams to do that. It makes people feel better at times, but here's the way to get around that with the next person that wants to feel better with that. Because normally the person asking you that is somebody pretty high-powered in the organization, some exec. What you do is you say, yeah, I'll estimate for you, but I'm really curious. I know you're a golfer. When you go out and golf this weekend, what are you going to shoot? And they'll give you one number. They will not give you 18 numbers. They'll give you one number. Ask them to then break that down hole by hole, right? And what they're going to come up with will not be the same number they came up with when the 18, when they gave you the aggregate number. Well, that's what consultants are good for, because we don't care if we get fired, right? So we can ask that. The point of that is when we break things down and then we add them up, we often introduce more error into the estimating process, right? Absolutely, absolutely. Lots of drawbacks to doing that, which is why I don't want to do that, which is why I want a process where we can put high-level, easy-to-come-out story point numbers. Let me back up and put them up there. Notice I put the smaller numbers back. Right? I want to do that. Now, here's why this won't happen with story points. No one's going to take this and say, well, we've got 10, 14 story points left. Let's divide them by 35 hours. 14 story points divided by 35 hours. I don't even know how to do that. They're obviously different units. Let's not divide them. And somebody will say, well, how do I get the answer I want? And they'll say, well, you take the 14 story points remaining divided by the 3 we did, and they'll do the right math, right? So it won't happen when we have clearly different units, okay? Which is why hours are the most troublesome. Days are almost as bad because we're just forcing somebody to multiply by 8 before they can make the mistake. Yes? Feedback loops in what sense? Getting better at estimating?
So if you release things, you have your first product, you release that estimate, it's testable, people try it out, get out, release things like that, and people have feedback
I'm missing the feedback. They have new features?
not necessarily features, but within the way you designed it, wasn't necessarily
Changes. They would just be new product backlog items, right? And we would have to estimate the new product backlog items. Right? And I would encourage that. I mean, we always want new ideas, right? So I'm kind of opposed to like the idea of change control boards, right? Come up with a new idea, let's put it in. All we have to do is have a prioritization process to make sure we're working on the highest priority things.
I know that these are short-term sort of things. You don't want to put a lot of information.
Correct.
But you could put like sensitivity analysis, sensitivity numbers, give or take this amount, and there may be some dependencies for that. This number is for this typical point for that.
Yeah, I won't talk about it. So the question is, you want to do sensitivity analysis and things like that with this? What I've done to get around those type of things is I've done 2-point estimating. So I'll say, what's the most likely number for this? And I'll say, we could be done in 5 points or 5 days, whatever you're thinking in. And as a worst case, it might take 15 days, right? And put some ranges around our estimates. Then there's ways to aggregate those and reduce that down. And sometimes that's relevant, right? Sometimes that's relevant. So I want to talk about how to combine these into an estimating approach. So we're going to talk about a tool, a technique called planning poker. Planning poker is very loosely based on a technique called Delphi or wideband Delphi out of the Rand Corporation in the 40s. The idea with planning poker is that each estimator is given a deck of cards, and the cards have the numbers on them that we've agreed to use as an estimating sequence. The estimators talk about the item to be estimated. The product owner typically is there, reads it to the team. The team talks about it, and once you think you've got an idea of what the answer is, you pick the number out of your deck. Okay, I think it's a 10. So I've got a 10 selected. You think it's a 3. Now we all turn our cards over at the same time. Right? You're holding up a 3, I'm holding up a 10. Everybody else on our team is holding up a 5. Well, they want to hear from us. Why do I think it's a 10? So I give my argument. You give yours for why it's a 3. We talk about it as much as needed. Anybody else can talk and argue, but we especially want to hear from the outliers. Then we pick up our cards, we do it again. You can bluff if you want, pick the same number, right? Pick a number you want. Everybody's got a number, 1, 2, 3, we turn them over. We see if we agree. Once we agree, we're done. If we don't agree, we keep repeating this process until we do agree. Here's an example. So suppose you're holding this set of numbers. I want to explain this set of numbers first. This is kind of obviously the Fibonacci sequence. Take two numbers, add them together to get the third. 1 plus 2 equals 3. 2 plus 3 equals 5. 8 plus 13 equals 21, but you'll notice I've got a 20 up there. Let me explain the 20, but let me back up and explain that, start with a different explanation first. So I mentioned that I wanted to get good at estimating, and I told my teams you have to estimate different ways. I had a team come to me, and they showed me their estimates. They had an Excel spreadsheet. They had column A was the estimate, column B was the feature to be delivered. And I was just in a bad mood that day. I was the VP in this group, and the team was coming to me, and I barely even remembered what they were working on. I had way too many projects going on, and I barely remembered this. So picture the context, right? You come to this jerk VP who barely remembers your project. And one of their items was a 17. And I said, that's not a 17. I said, that's an 18. I said, in all my years of doing software, if I've ever seen an 18 in my life, that is an 18. And they looked at it and they said, oh, you're right. We told Bill, who was conveniently out sick that day, we told Bill to change that. We're not sure why he didn't, but you are absolutely right. That's an 18. They left, and I said, wow, I've got a really stupid team. But it was kind of fun. It was kind of fun doing this to the team. I just wanted to see how they'd respond. Another week or so, another team comes in to show me their estimates. They have the exact same thing. And I say, I'm going to have fun again. I say, that's not a 17. That's an 18. And they said, we don't use 18. I said, what do you mean you don't use 18? I said, it's a number. It's between 17 and 19. You have to use it. And they said, no, we found out that we shouldn't use every number. Right? We can't tell the difference between a 17 and an 18. So why let ourselves get in arguments about, oh, it's a 17, no, it's an 18. So we've decided to get rid of certain numbers. They left, and I said, wow, I've got a really smart team. I learned from them. This is great. Well, that project went on. It wasn't quite done yet. It was on schedule, but it wasn't quite done yet. But everybody liked what they were doing. The next team decided to start estimating. And they said, we'd like to do what that team has done. And I said, you can't. You got to do something different. They grumbled and left and came back the next day and said, okay, we've got it. We figured out what we're going to do differently. And what they decided they were going to do differently was, instead of rounding to the nearest number, which is what the first team did, they said, we're going to think of these things as buckets. Right? And I said, well, what does that do? It's a bucket, so what? And they said, no. If you think about it, if it's a bucket and you have an 18, it won't fit in a 17-gallon bucket. An 18-gallon item has to go into the next biggest bucket. Well, that's kind of good. That'll help this kind of human nature tendency to underestimate, right? We have something big, we put a number on it, but then later when we break it down into the tasks, it explodes into something bigger. Well, this rounding up idea sounded pretty good, the bucketing idea. Let's try it. So they went off and did that project. They got about halfway through and it was going really well. The next team came to me and said, let's call the experiment off. We've learned how to estimate. And I said, we're not even close to done. Go find a tweak. Go do something different. They came back. They grumbled and complained. They came back the next day and said, we've got it. We're going to think of them as buckets as well, but they're not buckets of water. They're buckets of sand. I said, what does that matter? Right? They said, oh, it matters a lot, because if we use a 17, we actually can put 18 gallons of sand in a 17-gallon bucket, right? It would be heaping, right? This left them the capability to say things like, well, lion and tiger. A lion's just a little bit bigger than a tiger. I want to call it the same number, right? So, okay. And I said, well, have you defined how much is too big? When does it roll up? And they said, no. That'll be decided in, the context of each item. It's just that we feel that there's room to go a little bigger. I said, great, go that way. So that team estimated that way, and that turned out to be fairly successful. The next team was doing stuff. Might not have been the next team. Might have been a couple teams later. But one team was doing something, and by then we'd settled on the Fibonacci sequence as a good set of numbers. And this next team was explaining their estimates to their product owner. And they said, okay, this one here is a 21, and they talk about it. And the product owner said, I'm impressed. I'm really impressed that you know that's a 21, not a 20. You must really know something to call it a 21. And the team said, oh, no, we use the Fibonacci sequence. This is all back before Da Vinci Code was out, right? Which reminded us all what the Fibonacci sequence was. And the product owner said, the Fib what? Right? And the team said, oh, we'll just call it a 20, right? And from there on, we decided, it looks like you've got some very precise knowledge you don't have. This one's a 34, right? That'd be the next number, right? So after a while, we deviate from the Fibonacci sequence. So we use up to 13 and then 20, 40, and 100. So I do call this the Hanks sequence. So in an estimating meeting, we're doing this, and we get the first 4 estimators, a 3, 8, a 2, and a 5. I'd want to hear from Vadim, why an 8, and why a 2? And Vadim says, this is going to be hard to test. We've never tested anything like this. This will be challenging. And why a 2? Well, Vadim's right. This will be harder to test than I was thinking. My 2 is wrong. I'm going to come up on the 2. But this will not be that hard to program. I've done this before. I did this on my last project. No, the code's not reusable, but it's not going to be that hard to do. I think it's fairly simple. Everybody picks up their cards, they re-estimate, and we see that we get 3 5s and an 8. At this point, I would ask Chris, give us an impassioned plea for an 8. The rest of us have 5s. You tell us why this should be an 8. This is not a vote. We don't go with majority rules, right? We hired Susan, Vadim, and Ann yesterday. Today's their first day on the job. Chris is the founding architect of the company. He has a little bit more credibility. Let's go with whatever he or she says, right? So this is not a vote. It's not a democracy. We drive this till we get consensus. I want to hear everybody say, I agree. That's the one number to put on here. I've always asked, well, what if that doesn't happen? I don't know. I've never seen it happen. Every team will get to consensus. They may have some items that get kicked out. Product owner, go get some more information, right? We can't tell. That may be if the case here where Chris is old enough 100, right? We don't know how we're going to do this. We don't have enough answers. Go get some more information. We'll estimate this in a couple days. But normally you will get to consensus. The consensus may be false. What I mean by that is Chris may go a couple more rounds and just say, I fold, go with a 5, but please remember.